Trigonometric function of angles. A trigonometric function of an angle relates an angle to the ratios of sides in a right triangle.
So here we move to terms. So first we have the hypotenuse. So hypotenuse has the longest side of a right triangle. It has the slant side. It is always the opposite of the right angle. Next is opposite. Side across from the chosen angle theta. It does not touch theta. Changes depending on which angle is used. Lastly, adjacent. Side next to angle theta helps form theta with hypotenuse, not the hypotenuse.
Functions. Shown below are different types of functions. Sin theta equals opposite over hypotenuse.
So here we have cos or cosecant is cosecant theta equals adjacent over hypotenuse.
And here lastly we have tan. Tan theta equals opposite over adjacent. Sin. The sin of an angle is the ratio of the opposite side to the hypotenuse. How tall compared to the slant? Sin theta equals opposite hypotenuse. That is the given formula. Example problem. A ladder is leaning against a wall. The ladder is 10 meters long and makes a 30-degree angle to the ground. How high up the wall does the ladder reach? So the given hypotenuse is 10 meters. The given angle or theta is 30 degrees. So since we are following the given formula, we should input to the calculator sin equals sin 30 degrees parenthesis, and it will show 1/2, and then next you transfer that 1/2 into a decimal form, which creates 0.5. So 0.5 equals opposite over 10. The next you multiply the hypotenuse and the sin. 0.5 times 10 equals 5. Second problem. An airplane takes off and climbs at an angle of 15 degrees to the ground. After flying in a straight path, it has traveled 2,000 meters along its flight path. How high is the airplane above the ground? So the given hypotenuse is 2,000 meters and the given angle or theta is 15 degrees. Using the same formula again, we should input the given angle, which is 0.259 equals opposite over 2,000, and then 0.259 times 2,000 equals 518 meters, which is the opposite. Third problem. An airplane is flying at an altitude of 2,000 meters. If the line of sight from the airplane to a point on the ground makes a 25-degree angle to the ground, how far is the airplane from that point? So now, what we are looking for is the hypotenuse, because distance to the point. Angle is 25 degrees and opposite is 2,000. So using the formula, we will now find the hypotenuse, because the sin and the opposite is already given. So we just do the same thing again, like what we used with the other two problems. We use sin and we input the angle. We multiply that by the given opposite, which is 4,728 meters.
So cosecant or cos. The cosine of an angle is the ratio of the adjacent side to the hypotenuse. So how wide compared to the slant? So here we have the formula cosecant theta equals adjacent over hypotenuse. Here, our first problem. A ship sails directly toward a lighthouse. The ship's radar measures the distance to the top of the lighthouse as 120 meters. The angle of elevation from the ship to the top is 30 degrees. How far is the ship from the base of the lighthouse? So here we are trying to find the distance, the distance of the ship from the base of the lighthouse. So here we have the given, which is hypotenuse equals 120 meters, and the angle is 30 degrees. So here in the adjacent, this is what we are looking for. So let's start. So cosecant is equals to adjacent over hypotenuse. So here we have to put the angle, and the cosecant, which is 0.866, and we have to put the hypotenuse below the adjacent, which is all we have to do is multiply the hypotenuse and angle if we're looking for the adjacent. So 0.866 times 120 is equals to 103.92 meters. Next problem. A flagpole is supported by a wire that makes a 40-degree angle with the ground. The wire is 10 meters long. How far is the flagpole's base from where the wire touches the ground? So here in the given, our hypotenuse is equals to 10 meters and the angle theta is to 40 degrees. And then the adjacent is what we're looking for again. So what we're looking for is the distance again from the flagpole to the wire that touches the ground. So here we have to convert the angle to a decimal. So cosecant 40 degrees is equal to 0.766, and again we'd have to put the hypotenuse below the adjacent, and we'll have to multiply it from the angle. So 0.766 times 10 is equals to 7.66 meters. Last one. A crane's arm is 40 meters long and makes an angle of 55 degrees with the ground. How far is the tip of the arm horizontally from the base of the crane? So what we are looking for here is the distance of the tip of the arm from the base of the crane. So here our hypotenuse is 40 meters and the angle is 55 degrees. So again, this is the last problem. We are looking for adjacent. So cosecant 55 is equals to 0.574. And here hypotenuse is below the adjacent, so it is 40 meters. So again, we'll have to multiply it, and here we will have 0.574 times 40, and the adjacent will be 22.96 meters. So lastly, this is the next problem, which is the last. A building casts a 30-meter shadow. If the angle of elevation of the sun is 60 degrees, how tall is the building? So here, our problem here is finding the hypotenuse, which is how tall the building is. So here, the angle is 60 degrees and the adjacent is 30 meters. So here we'll have to convert the cosecant, which is 60 degrees, into a decimal. So cosecant is equals to 0.5, and here we'll have to divide the adjacent and the angle, which is adjacent is above and angle is below. So after we divide, we will get the hypotenuse, which is 60 meters.
Tan is the tangent of an angle. It is the ratio of the opposite side to the adjacent. How tall compared to wide? Tan theta equals opposite over adjacent. That is the given formula. A person standing 30 meters away from a building observes the top of a building at an angle of elevation of 50 degrees. How tall is the said building? So, what we were given was the adjacent of 30 meters, the angle of 50 degrees. And what we are looking for is the height of the building, or how tall the building is, which is the opposite. Just like the other two, sin and cos, we will get the given angle and we will put it in the tan in the calculator. What's given is 1.918. And the next we will follow the formula. Tan theta equals opposite adjacent. Since we already have the tan and the adjacent, now we will just multiply them. 1.918 times 30 equals 35.75 meters, which is the opposite.
So here is the next problem, and here is the problem. A ladder leans against the wall and makes 60-degree angle with the ground. The bottom of the ladder is 4 meters away from the wall. How high up the wall does the ladder reach? So here we are going to find out how high does the ladder reach. So here we are going to find the opposite, which is the height reached. In the adjacent, the distance from the wall is equal to 4 meters, and the angle theta is 60 degrees. So here we are going to convert the 60 degrees into a decimal, which is tan 60 degrees is equals to 1.732. So here the adjacent, which is below the opposite, and just like cosecant, we have to multiply the angle in the adjacent, and here we will get the answer from the opposite, and all we have to do is multiply, which is the answer is 6.928.
Second problem. A tree casts a shadow of 8 meters long. If the angle of elevation of the sun is 40 degrees, find the height of the tree. So what we were given was the hypotenuse of 8 meters and the angle of 40 degrees. So since we are looking for the height of the tree, we will now follow what is given. So first we will input the angle, and the next we will follow what is given in the formula, which is 0.643 opposite over 8. So now we will just multiply our sin and the hypotenuse, which equals to 5.144 meters, which is the opposite. Real world applications. Sukatawa can be used in many different kinds of applications throughout our daily lives. For example, in engineering, we can measure the height of the buildings, the height of the materials needed and the woods, or measuring the height of a tree. By standing a certain distance away and measuring the angle of elevation using a protractor or clinometer, you use tangent or tan theta equals opposite over adjacent to calculate the height, which just shows how we can use these kinds of real-world applications in our daily lives.
So next is architecture. Engineers use trigonometric functions to design sloped roofs, ramps, or bridges by calculating the correct angle for safety and stability. That way, the one who will be living under the house will be safe.
Navigation. Sokatawa can be used in navigation through ships and airplanes because they use sin and cosine functions to determine their direction and shortest path when traveling across the globe, which enhances the time used and the materials used to travel.
So lastly, sound and light waves. Here, both sounds and light travel in waves, which can be modeled using sine and cosine functions to study amplitude, frequency, and phase.
Here are some tips when solving these kinds of problems. Sin. When using sin, you use sin when the problem involves the opposite side and the hypotenuse. For the opposite, The side across from the chosen angle theta does not touch theta, and it changes depending on which angle is used. And lastly, for adjacent, the side next to angle theta helps form theta with hypotenuse, not the hypotenuse. Thank you for listening.